Hi guys, question 6 in the couples booklet always causes some consternation among students. Why? Because it introduces a tricky little part to understanding the way couples actually work. Now, if we're thinking about when an object is cantilevered off a structure, and this here is a lamp post, we've got the weight of the bracket and we've actually got the weight of the lamp. So we've actually got two forces to consider here. But essentially, both of those forces will tend to create a clockwise rotation. Now, we can easily visualise this. We can see this is sticking out. If we were to pull those bolts out, it would want to fall down and rotate down as it fell. So, remember the bolts do two things. The bolts are both holding this onto the post so it can't rotate off. The other thing that the bolts are doing is that they are stopping it sliding down. So there's a shear force in the bolts and there's also a tensile force in the bolts. Now, the problem with this question tends to be that most students don't realise the role of the bottom bolt. And I know I explained this in class the other day, but I really want to sort of dig down into it a little bit more because it comes up in lots of couple questions. Now, in the pot plant question that we looked at, it didn't have a bolt or a screw at the bottom. It only had the one at the top. So the one top screw was doing its job, holding it back against the wall, stopping it rotating off, and also stopping it sliding down. Now here we've got two bolts. So why do we have two bolts? Well, they share the vertical load, so there's less shear load on it. But this bolt here is not stopping it rotating off. It's there probably for other reasons, mainly to lessen the shear load, but also maybe sideways loading that may occur as well. So, in its current situation, when this force here tends to create rotation and this force tends to create rotation, what we're getting is we're getting vertical reactions here. So we get a vertical reaction of this force, they then create a couple. We get a vertical reaction over here to this force, they create a couple. In other words, what we have is two couples that are being created. In this case, the bracket is 60, so it's 60 newtons times by 1 metre, and this one is 120 newtons times by 2 metres. So we add those two couples together. Now, they obviously create a force couple over there at the post, which is what we're going to look at for the first part. But the kicker for this question is the second part. A lot of people get that wrong. Now, notice here, multiple couples can be added together. Couples are like moments. If you have multiple couples, they add together. So if you think that the total reaction here is going to be 180, because we've got 60 and 120 added together, we can consider it a 60 is reaction to that, and a 120 is reaction to that. They've got our two couples. Therefore, the total vertical load will be 60 plus, the total vertical reaction, I should say, will be 60 plus 120, which is 180. Now, if we have a look at this question here now, let's look at it in our free body diagram form. We've got 120, we've got 60, we've got our two vertical reactions there, which give us a total of 180. And the first thing is describe the force couple at the pole. Now, this is the action at the pole. So what we've got is we've got a total couple of 300 newton meters going clockwise. This is trying to rotate it clockwise. That's the action. And we've got 60 plus 120, 180 newtons going down. So we tend to get 180 newtons going down, 300 newton meters going clockwise. That's the action at the post. But what is the reaction? Well, obviously it's the opposite of that. 180 newtons going vertical, and we've got 300 newton meters going anti-clockwise. But why is this 0.25 meters? Now, I know some of you know, and some of you may be a little bit confused. If we go back to the question without the answer on it, let's zoom in on that and see what we can come up with here. So, if we look here at this one, what's happening here is we've got the tension load in the bolt there like that. But when this goes to rotate off the wall, we don't get a reaction there, equal in magnitude, opposite direction. No, what we get is we get it down there. So these two constitute the couple. Now, why is that there? Because as this goes to rotate off the wall, that's going to push right on that spot there. right on that spot there as it comes off the wall. If that bolt was to let go, it would start to rotate about that point. So even though that bolt is there, it's actually not helping with this couple that we're having created here. So as a consequence, the clockwise couple's rotating off the wall. We can establish a 300 Newton meters clockwise, but the 300 Newton meters anti-clockwise going back this way, we're going to need to get that from those two forces that are there. So let's have a look back at our answer and see how that comes about. So if we scroll down to that, what we've got is we've got the clockwise couple, 60 times 1 plus 120 times 2. We've got force in the bolt horizontal times by 0.25, not 0.2. And so that gives us an answer of 1200 newtons. So your tension is 1200 newtons because of that key difference. So whenever you see a couple where we have something hanging off a post like that, something in a situation where it's cantilevered off, but the bracket actually is lower than the bottom bolt, that's the key point for you to consider when you're calculating the reactive couple.